NCTracer enables users to create and add custom Java and MATLAB plugins for image processing as well as trace editing and analysis. In this video, I will show you how to create a function in MATLAB and build it as a Java package that can be added as a plugin to NCTracer. The image stack, the adjacency matrix, the position vectors of trace vertices, and the branch calibers are native variables of NCTracer that can be used as inputs. These can be modified and returned as outputs of the MATLAB function. More information about these native variables used by NCTracer can be found in the documentation. The MATLAB function that I have here, named treeLengths, calculates the lengths of all the trees in the trace. This function uses the labeled adjacency matrix and the position vector variables to determine the length of individual trees. The length of each tree is stored into an array called lengths, which is the output of this function. Furthermore, a histogram of the tree length distribution is plotted and the array is saved into a .mat file at a pre-specified location. I'll save this function onto the desktop. This function needs to be deployed as a Java package in order to add it to NCTracer. To do this, type deploy tool and press enter in the MATLAB command window. The dialog box enables you to create a new project. Set the project name to be the same as your MATLAB function. Choose a location to save the files and set the type field to Java project. Once the project is open in MATLAB, add a class with the same name as your function, which is treeLengths in my case. Using the add files option, associate the MATLAB function to this class and choose the build option. To add the plugin to NCTracer, navigate to the Manage Plugins tab in NCTracer and select the Add MATLAB plugin option. Since this plugin does not modify the trace or the image stack, I will choose the None of the Above option in the dialog box. Details about choosing the appropriate option for your function can be found in the documentation. Navigate to the project files which were created by the build option in MATLAB and choose the .jar file within the source subfolder. In this next window, I need to specify the inputs and the outputs for the plugin. These inputs and outputs must be in the correct order as determined by the MATLAB function I had written. My function takes only the adjacency matrix and the position vectors as inputs. To change the order, I can select and drag the rows to their appropriate position in that list. My MATLAB function also outputs an array called lengths. Since this is not a native variable, I must add one parameter to the output parameters list and select its correct type. The order is irrelevant in the outputs list for my case because there is only one output parameter. Once these parameters are correctly set, click on OK. Depending on the option selected for the plugin type chosen in the initial dialog box, the added plugin will appear under the Custom MATLAB Plugins button in the Image Processing tab or in the Trace Editing and Analysis tab in NCTracer. In my case, the plugin should show up under the Trace Editing and Analysis tab. To test my plugin in NCTracer, I'm going to load a library that contains a trace and choose the plugin to run it. The histogram is opened in a new figure window and the pixel length of each tree is displayed in the console. My MATLAB function also saved this array into a file on the desktop. So let me check if running this plugin generated the file as well. This plugin worked as expected for me, and I hope this video allows you to start writing your own plugins for NCTracer.